Hello everyone, let's review for our law of sines and cosines quiz, and we'll throw Heron's formula in there too. So we know the law of sines. You have this formula where you can create a proportion. You need a side angle pair to do the law of sines. And now we know the law of cosines, which if you don't know two of the angles, you're probably going to need law of cosines, or I guess if you know all three sides. So the way I want you to remember this is if it's angle, angle, side, angle, that's two of the angles, which really means you have all three because you can always subtract from 180. Or the tricky one is side, side angle, and that's that ambiguous case, which we're going to do a couple problems to talk about. That's the trickiest thing about the law of sines. These two are going to be pretty easy. Law of cosines, that's if you're given all three sides or you're given the included angle, the one in between, but not the side across from it, so you can't do law of sines. So we'll go through these and I'll tell you sort of my strategy and then I'll work it out. And if you can do all that, you're going to be in great shape. So first thing, it says, what information are you given? These are three lowercase letters. That's side, side, side. So I know I'm going to have to do the law of cosines. And I always like to draw my picture just so I have a place to label it. It's really easy to mix up letters if you don't have it drawn, I think. So there's my picture. I have side, side, side. Now, that means I know I'm doing the law of cosines, so I'll take these formulas and just kind of steal them for a second. Cut. Try that again. Cut. And then we'll go back here, and I'll bring them onto this page so I can reference them. Paste. There you go. All right. So if I want to find an angle, I know I'm going to have to use either of these three. Those are the three angles in the law of cosines. It doesn't matter which one. I'm going to start with A. Let's just solve A first. So to find angle A, I'll fill in what I know. A squared equals A squared, 8 squared equals B squared plus C squared, 9 squared plus 10 squared minus BC, 9 times 10, 2 times 9 times 10, and that's times the cosine of A. These are the tricky ones to type in. So when you type these in, you need to make sure that you understand that you want to do it in two steps, I think is the best way to do it. I'm going to subtract the squared terms, 8 squared minus 9 squared minus 10 squared. And then I'm going to divide by this product. It's 180. 2 times 9 is 18 times 10 is 180. I'm dividing by negative 180. But if you type it in one step, negative 2 times 9 times 10, you can go ahead and just put in parentheses, and you don't have to know that it's 180. Just type it in parentheses and divide. And that's the cosine of A. If that's the cosine of A, then you find the inverse cosine of that, and A is 49.5. A is 49.5 degrees. Which is, if you can do it once, you can do it over and over again. You just have to learn how to type that in. I'm going to do the same thing I'll do B now. This is 49.5. Now I'm going to use the same formula for B, so I just plug in different numbers. B squared, 9 squared. It's always the other two. AC are 8 and 10, so 8 squared plus 10 squared minus 2 times 8 times 10, cosine of B. So I'm going to subtract and then divide. 9 squared minus 8 squared minus 10 squared. Divide by the quantity, negative 2 times 8 times 10. Not 11. And you get 0.518. Remember, that's the cosine of B. So do inverse cosine, and you get 58.8. B is 58.8 degrees. 58.8 degrees. Now, once you have two of the angles, you can subtract and get the third, but I never want to round anything, even though sometimes you're tempted. I'm just going to do 180 minus this decimal with all of them, minus this decimal with all of them, and we'll see what I get. So 71.8. C is 71.8 degrees. So now I have A, B, and C, and I already had little a, b, and c, so I'm good. I got all three sides and all three angles. So that's it. If it's side, 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 you're going to have to use the law of cosines to find two angles. What else do you got here? This one is, let's draw it. A is 25 degrees. So we'll say A, B, C, 25 degrees. Little b is 15 and little c is 9. All right, so this is side angle side. We have the angle that is included between these two, the one that's between them. Now, you'll notice you do not have an angle side pair. You don't know everything about C, you don't know everything about A, and you don't know everything about b. So you have to use law of cosines. This is law of cosines because I don't have an angle side pair. When you do law of cosines, if you don't know all three sides, that's what you should find first. So I'm going to find little a, and to do that, I'll use my formula right here for little a, this guy, and this is going to be the easiest thing you can do. A squared is b squared plus c squared. So 15 squared plus 9 squared minus 2 times 15 times 9 times the cosine of, we do know angle A is 25. So since you know everything on this side of the equation, this is a lot easier to type in. I'm just going to go ahead and plug it all in. 15 squared plus 9 squared minus 2 times 15 times 9 times the cosine of 25. That is the squared. You need to square root that to get 7.8. So little a is 7.8. I think it's 7.83. Yeah, 7.83. But again, I'm not going to round that 7.83 when I do any of my calculations. I'm only going to round at the very end when I write down the number. So in my calculator, I'm keeping all those decimals. But for now, I'll just say a is 7.83. Now, you do have a choice. You could do law of sines, but since we're using side angle, well, I guess we could do angle side angle. We know everything about this one. So I could do law of sines for this. That's probably fine. If it's angle side angle, I don't have to worry about the ambiguity. So we'll do law of sines, I suppose. You know what? I said do law of cosines. Let's just stick with it. Let's stick with law of cosines. We'll do b. We'll do b using law of cosines. It's the same as the one I just did. So let's find b using law of cosines. B squared, I know b squared. B squared is 15. A squared, I know a squared, 7.83. Again, I'm using all the decimals. Plus c squared, 9 squared, minus 2 times 7.83 times 9, and that's the cosine of b. So this is like what I did before. 15 squared minus that whole thing squared minus 9 squared, and then divide by negative 2 times, I'm going to go get that decimal again, 7.8 times 9. That's the cosine, so inverse cosine will get you 81.3. Wait, let me try that again. I feel like that's wrong. Oh, it's not, it's whatever, 11. It's 15 squared. Try that again. 15 squared minus, I was like, I don't think that's right. 7.83 squared minus 9 squared. So we do the same thing. Divide by negative 2 times 7.8 times 9. And then I'll do the inverse cosine of that. 125.9. So B is 125.9. See, you got to be careful. You're using 15 for little b, not 11. I think I might have just double tapped it, but that's okay. We got B is 125.9. We already have A, so I can do 180 minus 25 for angle A minus this guy, and that'll get me angle C, 29.1. C is 29.1 degrees. All right, cool. Okay, so I found the missing side, and once you have the missing side, then you can go back to what we did over here and find the missing angle. With law of cosines, you're either going to have to solve for two angles or one side and then one angle. Because once you have one angle, you can find the other angle. Same thing here. Once you have two of the angles, you subtract, you get the other angle. All right, let's get moving. What else you got? This is angle side angle. Oh, no, that's number 4 is angle side angle. Number 4 is going to be easy. It's completely solved for the ambiguous case. All right, so they're telling me this is going to be an ambiguous problem. Now, just because I want to always try and draw it the same way, I'm going to see if I can flip some stuff around here. I'm going to make this C and this B and this A. 42 degrees, 35, 34. Just because that's the way we've been orienting it to visualize it, I'm going to draw it that way. So we have side-to-side angle, and I want to kind of run through the things that can happen. It's possible that 34 is just not long enough to even reach the base of this triangle, in which case there will be no solution. Or it's possible that it's a little bit too long, and then we could draw it two different ways. You could either take the extra length and bring it in to the left or to the right. So you could say like that triangle and that triangle until it becomes isosceles. At 35, it's isosceles, and then it'll only be one more triangle. Since 34 is less than 35, I think this is going to be ambiguous. And because the directions say it's going to be ambiguous, I feel like it's going to be the two triangles. So let's see how that pans out when you do the math. The law of sines, we're going to first have to find angle B, because even though we have an angle side pair, we need to find angle B. So I'll say the sine of 42 over 34 is the sine of B over 35. Now I will cross multiply. So 35 times the sine of 42. Come on, calculator. 35 sine of 42 divided by 34. Okay. That's the sine of B. Now I need to do inverse sine and get 43.5. So B is 43.5, the way I have it drawn right now. But it's possible that instead of going out this way, I could have drawn it so that I go in like that, and I have this obtuse triangle like that. So what you have to do to check is just to see, is it possible for that to fit? If I do 180 minus that, I get 136. If you add 42, you're barely less than 180, but it does fit. It is less than 180. It's going to be a really small angle, but it does fit. It's less than 180, so there is room to have like a 1.5 degree angle in there. So what that means is you could draw this triangle another way where you have this very obtuse angle. This is still 42. This is still 35. This is still 34. We have C, B, and A. But now instead, this angle B would be that other number I said, which was 178.5. 178.5. It's like almost a horizontal line. It's so obtuse. Now I'm going to have to solve both of these triangles completely. So the first thing I'll do is find my missing angles. So I'll do 180 minus 42 minus the 43.5, which again, I'm keeping all the decimals. So this is 94.5. 94.5, or I could do it with the other one, and I'm going to get a crazy small. Oh wait, it's not 178. It's 136.5. This is 136.5. The 178 comes from adding the 42. So I need to do 180 minus that to get my other angle C, which is very small, 1.5 degrees. Okay. 1.5 degrees. All right. So very small angle. Now that I have all three sides, I have angle, side, angle on both these triangles. I'm just going to solve for missing side A, but I have to do it twice. So I'll say the sine of 42 over 34 is the sine of A, which I know, 94.5 divided by little a. And down here, the sine of 42 over 34 equals the sine of 1.5 degrees over little a. So I just have to cross multiply twice. So we'll do 34 times the sine of that 94.5 angle, don't round, divided by the sine of 42. And that's one of them, or 34 times the sine of the 1.5 angle divided by the sine of 42. So either little a is 50.7 or 1.3. 50.7 or 1.3. And if you look, do these triangles make sense? Is the biggest angle across from the biggest side. Here, the biggest angle is 94. The biggest side is 50. The smallest angle is across from the smallest side. That's good. And obviously, if you have a really small angle, you're going to get a really small side. So those are across from each other, and the biggest is still across from the biggest. So we did it right, I think. Feel good about it. There's two triangles, though, and drawing them is a little tedious, but sometimes that's the way it goes. All right, let's do one that's a little easier. This is angle, side angle, so I can do law of sines. I'll first find missing angle A. Subtract from 180. 180 minus 28 minus 122. 30 degrees. Ooh, 30, that's nuts. So I'm going to get a circle, that's nice. The sine of 30 over 33 is the sine of, let's find little b, 122 over little b. And then I'll just set it up, because I'm going to do the same thing. The sine of 30 over 33 is the sine of 28 over little c. These are easy to type in. You just cross multiply. So 33 times the sine of 122 divided by the sine of 30, which is It's the same as multiplying by 2. Sine of 28. So 55.99, or we'll say 97, 55.97 and 30.99. 55.97 and 30.9. Is that right? 30.99. Yeah, okay. So this is little b, and this is little c. Let's label that, see if that makes sense. 30.99, 55.97. So across from 28, smallest angle, smallest side. Across from 30, smallest or middle. Good, big, good, awesome, great. Okay. Once you have two of the angles, law of sines should be pretty smooth. Let's do a few more. All right, another angle side angle problem. Great. First thing we'll do is subtract from 180 to get the missing angle. 180 minus 83 minus 38 is 59. So the missing angle is 59. Now I have an angle side pair. So the sine of 59 over 25 is the sine of 83 over little c, or the sine of 59 over 25 is the sine of 38 over little a. Nice c. Okay, so I just cross multiply and divide both times. 25 sine of 83 divided by sine of 59, and 25 sine of 38 divided by sine of 59. And that is, so 28.9 and 17 point, let's see, 28.95, 17.96. 28.95, 17.96. So that's little c, that's little a. Does that make sense? At least as far as can I draw that triangle? Is the biggest angle across from the biggest side? Yes. And then the smallest, yep, good. So as long as you check that, that's usually a good sign you're doing things right. Ooh, whoa, weird. Okay. What else you got? Side-side angle again? All right, so here's another side-side angle problem. So I know I got to have my heads up here. This could be tricky. Side-side angle could be ambiguous. We'll do the sine of 71 over 18 is the sine of c over 15. So I'll do 15 sine of 71 divided by 18. That's the sine of c. So c is either 52 or 180 minus that. But if you pick 128 and you add 71, that's bigger than 180. So it turns out this can't happen. It can't be 128 because 128 plus 71 is too big. We don't need to worry about that one. It's going to be 51.99. So this is 51.99 degrees there. And now that I have that, I know there's only one way to draw it because you couldn't fit the other angle. So I'll subtract to get angle B. 180 minus this guy minus 71. Now I got angle B. It's 57. 57. There's a really tiny decimal in there, so they don't add up quite to 180. And now I can just go ahead and do, let's do law of sines to find what I need. Just missing side B. So I'll do the sine of 57 over little b is the sine of 71 over 18. Now, if you have a choice between using information that's given to you, 71, or using information that you found, pick the information that's given to you. You know it's right, and you don't have to worry about any of this rounding stuff. So 18 sine of 57 divided by the sine of 71, oops, gets you 15.9697, 15.97. So little b is 15.97, I think. And if you look at it, biggest angle is across from the biggest side, and the smallest angle is across. Okay, cool. So I feel good about that. Okay. Once you have the proportions, law of sines, pretty quick. All right, so let's talk about this SSA a little bit more, the side-side angle deal. First thing, if I give you 2 bits of information, let's draw it. It's like, all right, 40 degrees, A, I'll call that C, and this is 40 degrees, and little b is 10. But what I want to know, first, what is the minimum length for the side? Right there, that length, if you were to draw it straight down, that's the shortest way you could connect those two. So I want to imagine it's a right triangle, and I'm going to say the sine of 40 is whatever that height is over 10. And then to solve that, this is right triangle trig, you just multiply both sides by 10. 10 times the sine of 40 is 6.43. Which means, if this is not at least 6.43, you can't draw the triangle. So the minimum length is 6.43. If it's not that long, it would just not reach. You would be like, this doesn't reach the bottom. Okay, I try and draw it, but if I measure it, it's short. It's got to be at least 6.43. Now, any value of a that will result in two triangles. Anything between 6.43, I'm just going to do it like this, and 10 is going to result in two triangles. I know it's 10 because that's when the triangle becomes isosceles. And when it's isosceles, you're not able to draw it two ways because the extra length would like swing outside of it. It doesn't make sense. So anything between 6.43 and 10, I'm just going to pick, let's say like 8. So I'll say little a is 8. And when I draw it, I'm going to draw it once where that distance comes in and once where that distance goes out. Try that better. Do better. Okay. So this is still ABC for both of them. It's still 40 degrees for both of them. And this is still 10 for both of them. But this BC, this segment right here, instead of drawing it always out like this, the other way you can draw it is you imagine that you take that extra length and instead of moving it that way, you move it in, and that creates this triangle. So both of these, the way I'm drawing it, I'll just call it 8. That is a distance between those two. So that would be two different triangles. I'm not going to solve them, but you just need to understand that that is a thing that can happen. And we did one like that earlier where we drew both. We did all of them. And you can go through your notes and see more of those if you like. But for now, it just says draw it. Great. I drew it. I can visualize it. If I needed to solve it, I could solve it. But it's anything between the minimum length and what would make the triangle isosceles. That's how you should think about it. And the last one says use Heron's formula. So Heron's formula, if you don't have your graphing calculator program, you can just take Heron's formula. It is very easy to do. I will do it with both modes. So first, let's do Heron's formula the old-fashioned, well, not really old-fashioned way because we have a calculator, but first you find the semi-perimeter. So 11 plus 7 plus 6 over 2. 24 divided by 2 is 12. Okay, then you multiply in one big square root. We know S is the semi-perimeter, half the perimeter, 12 times 12 minus 11, 12 minus 7, 12 minus 6. It doesn't matter what order you put these in, you just have to find the difference between the semi-perimeter and each segment. And now when I type it in the calculator, I'll do 12 times, I'll just do it in my head, 12 minus 1 is 1. 12 minus 7 is 5. 12 minus 6 is 6. Just save myself a little bit of typing. 18.97. So the area is 18.97. And we'll say 997 units squared. Great. Oh, it's feet squared. We know what they are. It's feet squared. Okay, feet. All right. That's doing it by hand. If you don't have a graphing calculator, that's how you're going to do it. If you do have a calculator that you programmed, let's see. Program, Heron's formula. Okay. A is, doesn't matter which one is which. 6, 7, the area doesn't care. 11. 18.97? Let's go. So I know I did it right. And if you wrote that program on your test, you're going to say, Mr. White, I wrote a program for Heron's formula. It's sweet. I'm like, I agree. That is sweet. Use it. Cool. I'm kind of curious because I want to show off my program. Do we have a side-side-side problem? The first one we did was side-side-side. So let's check this one using my side-side-side program, see how it goes. Program, side-side-side. The three sides are 8, 9, and 10. Did I get the same answers? 49.5. 58.8. Yes. Awesome. So if you want to write another program that's good, side-side-side is where I would suggest. If you've done the study guide, you've done all your checkpoints, you're going to crush this test. So that's all I need. Good luck. Hit that like and subscribe button.